distractions out of the table here. Yeah, thank you. Jed, sorry, not Jaren. All right, page 47, here we go. So I don't know how you approach this. The deal here is to show whether or not AB is parallel to CD. So I have to say something. I think a lot of my examples end up being the case that lines are parallel, but it's not always going to be true, okay? So you have to actually follow through and see if you can notice something. So this line parallel to that one, is it? Okay, so my goal is going to be, in this case, I'm interested in these two angles right here. What do we call those two? Alternate interior, and they touch the supposedly parallel lines. They both do, and they have that transversal in common, right? So this is your transversal, and so here we go. So how do I go about it? Let's check here. Is this line a diagonal? It is a diagonal as well as the transversal between these parallel lines, but it touches one vertex to another. So this is a diagonal here, which makes this a trapezoid. Okay? So that will allow me to solve for this angle right here. Okay? You can use inscribed polygons. However, I don't know the interior angle of this big polygon yet. So let's count that. So 1, 2, 3, 4, 5, 6, 7. So n is equal to 7. Okay, very important. Let's figure out our interior angle real quick, because none of these letters that are there are connected to the interior angle. So you have to do that on the side. Okay, so let's do that. The interior angle would be 7 minus 2 times 180 divided by 7. That is what, 127 something? Just have this up here. 28, sorry, 128.57. Okay, so that's my interior angle. Important, but it's not answering anything yet. But it's going to be for this one, I and I, capital I. So I'm going to find B, which is, right, these two are the same, remember? They're both the same measure. So I'll find angle B. It's 360 minus 2 interior angles. Okay, divided by 2. So angle B is going to be, well, let's do the top first. 102.86 divided by 2. And that amounts to 51.43 degrees. Okay, so angle B is there. That's important. And I'm gonna section that off, right, to keep my work organized. And so that I've got that. That's 51.43. And now I have to change strategy. I'm gonna attempt to solve for angle C. Can I call this anything? Is this? It's a 1, 2, 3, 4-sided. It's 360 all around. But you cannot use the inscribed polygon properties with this one. And this is why. It has 2 diagonals making it up. You would need, right, if you use this diagonal, you could use these sides here for sure. But you have a diagonal here and another diagonal. So this is not what we would call an inscribed polygon, right? You cannot use those formulas. So I'll put this on hold a little bit. I'll focus on A. This is a triangle here. Let's figure out angle A. That's 180 minus, there's an I up here, right? A capital I, which is 128.57. That result will be divided by 2, and so you get 25.72, that's correct. 25.72 degrees. Also important to me. Okay. And so now I can find C. Why is that? Here's why. Okay, last one. So B is 51.43, right? Let's write it in. 5143. And so is this one, 5143. Okay, this angle is 5143 as well. I found that this angle right here, I just calculated, is 2572. Okay. So now I can solve for this one. How would I do that? That's right. So if you didn't hear that, angle C, this one, I will go interior angle, which is the whole thing here, the whole thing at this corner, minus angle B, essentially, minus angle A. Okay, that's going to be the way I go about it. And so angle C is 128.57 minus 51.43 minus 25.72. Angle C ends up being 51.42, which is, yeah, it's a round, there's a rounding issue there. Okay, so there's angle C. So let's write that in. I'm going to use a different color. I'm going to go blue with this one. $51.42. And I'll highlight that one because that's the last piece that I need. So this angle is right here. Okay, that whole thing. And the other one, use a different highlighter. Use green for this one here. This is another important angle here. And I found that right there. So yes, it is messy. I won't deny that. Some of you might say, well, they're not exactly the same. This one is 51.42. This one is 51.43. Therefore, they're not parallel. If you answered that, I would be okay. I'll try not to do that to you. Like this is a rounding. It all stems from this rounding. Like when we state this interior angle, we round it. And so that carries through to everything we do. That's why it's not. It's supposed to be parallel, but due to rounding issues, it's not. So let's just say they're not in this case. So we have an example where things are not parallel, right? Angle B is not equal to angle C, and they are alternate interior angles. Therefore, AB is not parallel to CD. Okay, so these two angles here that we called alternate interior, they're not the same. Right? They're not the same. Therefore, AB is not parallel to CD. I think this is probably one of the few examples that results in lines not being parallel. Okay. All right. We're good? Fun stuff, eh? Let's keep going. I would like you, I'm going to give you some time yet to try this one, but for now let's just write it on there. Homework, page 48, in case I forget, okay? So put that down. So this page goes through exactly what we've just done. So you get to go at it again. So let's put that on hold, but I want to do tessellations as well.